on. Function
Here,
set.
reset that.
Oh, I didn't plug it in. Just gonna do it this way. Oh, this one sounds worse.
Today we look at more fake Technic power functions motors from eBay. A few months ago we looked at a fake buggy motor and it looked fairly promising, so this time I decided to get an M and an L. These again came from eBay and they cost about 10 bucks a pop shipped. For comparison, used M and L motors now cost between $20 to $30 on Bricklink, and that's before shipping. The motors shipped from China and they came in the same packaging as the buggy motor. I kind of suspect that one factory makes all these fake motors and you will get the same thing regardless of where you buy them. That being said, externally they look and feel almost the same as the real thing, but they don't have the Lego logos and the pinholes generally grip a little tight. I originally wanted to change our testing methodology. Mostly for convenience, I wanted to drive a static load rather than lift a weight. The clutch gears have a nominal torque, and we thought we could use them along with the speed computer to make a pure Lego dyno, but we first had to verify the accuracy of the rating. Of course, we used the weights to measure how much torque we needed to rotate the clutch gear. Over a handful of different samples, we measured an average of 1.5 Newton centimeters, significantly below the stated 2.5 to 5 Newton centimeters. We nonetheless started testing using this figure, only to find out that the clutch apparently increases as the gear warms up, probably explaining why the nominal rating is a range. Just as an aside, there are two different versions of the clutch gear with two different nominal ratings. As such, I ended up testing the old way, so let's look at the numbers, starting with the no-load speeds, which, quite frankly, looked way off the mark. Forward and reverse speeds seemed fairly consistent, but the fake M motor spun 45% faster than a stock M motor, and the fake L motor spun 27% faster than a stock L motor. It seems like this manufacturer had as much difficulty as we did in sourcing an appropriately slow motor. Like with testing the clutch gear, I used the coins from Train Pull to create specific loads for the motors. I again tried to approximate the torques that Philo used in his testing for both validation and comparison. 3.6 Newton centimeters on the M's and 6.5 Newton centimeters on the L's. The real M motor performed as expected, and surprisingly, the fake M motor performed similarly. More surprisingly, the fake L motor performed closer to expected than the real L motor. Despite having wildly different no-load speeds, both M motors output about 1 watt, suggesting that the power curves converge toward this load. The fake L motor put out about 1.7 watts, roughly 20% more than the real L motor, which output about 1.5 watts, roughly 25% less than expected. These power curves also appear to converge slightly as the load increases. I ran each motor several times and used the average RPM for the final power calculations. Here you can see the consistency of each motor. Some of the variation, without a doubt, comes from the manual nature of this testing, but either way, Just like the fake buggy motor, the fake M and L motors seemed less consistent than their real counterparts. So, how relevant are the theoretical differences between the real and fake motors? I tried to test them in a more practical scenario as I did with the buggy motors in the MP36 video. I ran the two M motors in the QJ and compared the speeds in both the low and high gears. In low gear, the fake M motor ran about 35% faster than the real M motor, and in high gear, the delta barely changed at all. This result seems a bit at odds with the earlier test, but I don't have a good way to measure the actual loads in this scenario, so they could fall anywhere on the power curve. Still, this strongly suggests that the performance between the fake and real motors can vary a ton in practice, and I probably would not use them for speed-sensitive applications, though I don't consider trains as such. Finally, I decided to look inside the fake M motor, since we have already seen inside a real one, and they come apart in the same way. Perhaps unsurprisingly, the fake internals look almost identical to the real internals, not quite to the point of being the same molds, but very close for sure. I did notice that they use a slightly thinner lubricant and more of it, though who can say what that will actually do for reliability. In conclusion, the performance isn't very close, but the fake motors are generally more powerful, and for some applications, the delta might not matter. Maybe you could also use these as spare parts to keep real motors running. On that note, this is the end of the video. Please consider subscribing and supporting the channel, and have a nice day.